The construction industry contributes roughly 9% of global GDP, yet for most of its history, it was built on sweat and physical leverage. Every beam, brick, and bag of cement had to be physically placed and manually accounted for. Tracking the cost of those materials fell to the quantity surveyor. In this role, the surveyor functioned as a human calculator, painstakingly tallying volumes and pricing out raw materials by hand using mechanical tools. This historical ledger illustrates the manual burden of the era. Handwritten rows of dates and material measurements meant that estimating a project required massive amounts of static paperwork, creating a slow and inflexible financial system. As architectural designs grew more complex, firms managed the workload through volume. They put more draftsmen and surveyors into crowded rooms, assigning individual drafting tables to manage the increasing calculation load. Because financial tracking relied on human brute force arithmetic, the industry was notoriously slow and reactive. By the time a cost overrun was identified on paper, the physical construction was often too far along to correct. That analog anchor was cut loose by Construction 4.0. This era prioritized digitalization and real-time data utilization, using tools like drones to cast digital scanning grids over physical sites. Building Information Modeling, or BIM, allowed software to instantly count every brick and beam in a 3D wireframe. It turned the manual tally into a live digital stream, where material lists and prices updated in real time. This automation created a sudden role crisis. If an algorithm can execute the primary counting and pricing functions of a quantity surveyor in seconds, the human value in the process begins to look obsolete. Seeking hyper-efficiency, firms began delegating procurement triggers and cost modeling permissions directly to these automated systems. Software was increasingly granted the autonomy to make financial projections and material choices without human intervention. This shift meant that trillion-dollar financial decisions across the global infrastructure landscape were being handed over to black box algorithms, effectively erasing human oversight from high-stakes project economics. Pure automation has hit a ceiling. Sites generate millions of fragmented data points daily, but it's unstructured data algorithms struggle to organize. Without a human logic layer, systems cannot decipher the subjective nuances of a tender or the commercial relationships hidden within the digital noise. The obsessive focus on automated efficiency also ignored the environment. By prioritizing speed and cost above all else, the industry's digital tools failed to account for planetary boundaries or carbon impact. Construction 5.0 is the attempt to correct this. It redirects technology to serve sustainability and society, putting the worker back at the center of the production process. Without a clear, rigid framework that prioritizes human well-being and environmental restoration, massive datasets and pure automation are functionally useless. Construction 5.0 introduces a collaborative work paradigm. Instead of machines replacing people, we see humans seamlessly guiding advanced robotics to handle high-risk or repetitive tasks. In this framework, the quantity surveyor levels up, evolving from a manual calculator into a cost custodian, a strategic advisor who uses technology to manage the financial and ethical health of a project. In this staircase model, foundational steps involve using AI to automate workflows and convert historical data into predictive intelligence. Moving up the tiers, the role shifts toward high-level strategy, evaluating life cycle sustainability, and establishing ethical protocols for data use. The ultimate trajectory is the role of the trusted digital advisor. This professional combines deep cost expertise with ethical governance to guide projects through complex digital ecosystems. By offloading raw math to AI, the surveyor becomes more essential. They act as the vital filter, turning digital noise into a sustainable, long-term strategy. This establishes the human-in-the-loop standard. Advanced AI systems are paired with, and remain subordinate to, human commercial judgment. A machine can flag a budget variance with rigid logic. It takes human intuition to recognize the contractor dispute or site complexity causing that variance, and decide on the most equitable path forward. Professionals now have an obligation to make ethical decisions about sustainable practices. Because AI cannot instinctively value the use of living green architecture or circular materials over a short-term margin, the true superpower of the modern professional is no longer calculating numbers, but possessing the instinct to know what those numbers mean in physical reality. Value in the built environment is now encoded deep within digital data. Every dataset is a potential source code to predict cost, inform design, and even anticipate future material reuse. Professionals who attempt to compete against algorithms on pure calculation speed will face rapid obsolescence. Survival requires cultivating a dual fluency, combining rigorous data literacy and systems thinking with high emotional intelligence and curiosity. The future of construction is a highly sustainable, human-centric industry guided by measured instinct.